This is the Algebra 1 semester exam review for Unit 2, Topic 3, which is questions 38 through 47. This is the last topic for the exam, and as I did in all the other videos, just a reminder that you are going to have this formula sheet with you on the exam, so make sure that you understand it and know how to use it so that it will be useful for you when you take your exam. Question 38. Joe's Body Shop charges $25 for parts and $50 per hour to fix the brakes on a car. Kathy's Body Shop charges $70 for parts and $40 per hour for the same type of work. Let X represent the length of time to fix the brakes on a car. A. Write an expression for the amount that Joe will charge to fix the brakes on a car. So we know that Joe's Body Shop charges $25 for parts, and then it's going to be $50 per every hour, so times X. Part B asks us to write an expression for the amount that Kathy will charge to fix the brakes on a car. Well, Kathy's Body Shop charges $70 for parts and $40 times the number of hours, $40 per hour. So when will the amount charged by Joe and Kathy be the same? Show you determined your answer. So to do this, we're going to set the two equations equal to each other because we want to know when will Joe's 25 plus 50x equal Kathy's, which is 70 plus 40x. First thing I'm going to do is subtract 40x, so they're all on one side. And that's going to give me 25 plus 10x equals 70. I'm then going to take away 25 on both sides. So I get 10x equals 45. Finally, I'm going to divide by 10 and get x equals 4.5. So the amount charged will be the same after 4.5 hours. All right, question 39 says, Brittany is planning a party with her parents. After collecting the following information from two possible locations, Brittany is meeting with her parents to help decide which location they should choose. Over the Top Party Palace charges $100 for use of their location plus $15 per person, and Make 'em Envious Emporium charges $300 for use of their location plus $10 per person. How will they determine which location they should use, or they should choose, and justify our answer? Well, first of all, let's make X equal the number of people, because that's what our unknown is. We don't really know how many people we're inviting, and that's going to change our price. So we've got two companies. We've got Over the Top, and we've got the Make 'em Envious. So we know Over the Top charges $100 plus $15 per person, so 15x. The Make 'em Envious Emporium charges $300 plus $10 per person. So the best way to determine which location they should use is to find out when one company is more expensive than the other, and that's going to start with us finding when they're equal. So 100 plus 15x equals 300 plus 10x. I'm going to take away 10x and get 100 plus 5x equals 300. I'm going to then take away 100, and 5x is going to equal 200. Finally, I'm going to divide by 5, and x is going to equal 40. What this means is that when we have 40 people invited, each location is going to cost the same amount, so it doesn't matter which one they cost. So, if they invite 40 people, the cost will be the same at either place, so it doesn't matter which one they choose. Now we need to find what happens when they invite less people and more people. We know that when they invite less people, one is going to be more expensive than the other, and when they invite more people, it's going to be vice versa. So let's say we invited 30 people. okay? Over the top is going to be 100 plus 15 times 30, which is 100 plus 450, which is 550. The Macom Envious Emporium would be 300 plus 10 times 30, which is 300 plus 300, which is $600. So, if they invited less than 40 people, over the top will be cheaper. If they invite more than 40 people, Macom Envious Emporium will be cheaper. So as I mentioned, if they invite less than 40 people, over the top will be cheaper. And if they invite more than 40 people, Macom Envious will be cheaper. We can also see this because let's say we picked 50 people. Well, 100 plus 15 times 50 equals 100 plus 750, which is $850. However, the Macom Envious would be 300 plus 10 times 50, which is 300 plus 500, which equals $800. So in the end, it really just depends on how many people they invite. Question 40 says, look at the system of equations below. We have y equals mx plus b and y equals 6x plus 15. Which of the following statements are true? A says all of the statements below are true. Well, we don't know that until we look at B, C, and D. B says if m equals 6 and b does not equal 15, then the lines are parallel and there are no solutions to the system. Well, this is going to be true because they're going to have the same slope but different y-intercepts, which means that they are parallel, and that means that there are no solutions. C says if m does not equal 6, then the lines intersect and there is one solution to the system. Well, this is going to be true because if m does not equal 6, then they have different slopes, which means they're going to intersect at one point, and that's going to be one solution to the system. Finally, D says if m equals 6 and b equals 15, then the lines are the same and there are infinite solutions to the system. Well, if m equals 6 and b equals 15, we're going to have the exact same equation, which means that the lines are the same and there's infinite solutions, which means that statement is true. Because all three of these are true, that means A is true, and we're going to pick A, which says all of the statements below are true. For question 41, look at the system of equations below. We have y equals 4/5 x plus 7 and y equals 3/4 x plus 7. What is the number of solutions for this system of equations? Well, we have different slopes, which means that we're going to have intersecting lines, which means we're going to have one solution and at that intersection. So B is going to be the answer to this question, exactly one solution. 42 says, look at the system of equations below. What is the y-coordinate of the solution to the system of equations? Well, we have x plus 5y equals 27 and x plus 3y equals 21. So, to find the answer to this question, we need to solve it. Since x and x have the same coefficient, we can subtract these equations. But you must remember that you need to subtract everything, which means that this is going to become negative and this is going to become negative. So, and this becomes negative, and we can change this to adding the two equations. X minus x is 0, these cancel out. 5y minus 3y is 2y, and 27 minus 21 is 6. Divide by 2, and y equals 3. If I wanted to solve this, I could then take this value of y and plug it back into one of these equations to find x. But we don't need to do that because it asked us to find the y-coordinate, which is b. Question 43. Old MacDonald has a farm with cows and goats. Each day, Old MacDonald collects 106 gallons of milk. Each cow produces 12 gallons of milk and each goat produces 1 gallon of milk. Each day, the cows and goats eat 420 pounds of food, and each cow eats 50 pounds of food and each goat eats 2 pounds of food. Let C represent the number of cows. Let G represent the number of goats. Write a system of equations to model the situation. Well, we're going to have one equation that deals with the milk and one equation that deals with the food. For the milk, we know that he collects 106 gallons of milk, and each cow produces 12 gallons of milk, so 12 times C for 12 gallons per cow, and each goat, so that's 1G, so each goat produces 1 gallon of milk. For the food, we know that he collects 420 pounds of food, and each cow eats 50 pounds of food, so 50 times C, and each goat eats 2 pounds of food, so 2G. So this is our system of equations, and now we're going to solve it to determine how many goats and cows Old MacDonald has. So I'm going to solve this using the method of elimination because I can see that if I take this first equation and multiply it by -2, I can then add the two equations together and G will cancel out. If you want, though, you could do substitution, and the best method for that would be to solve for this G and then substitute it in here. So I'm going to take my 12C plus G equals 106, and I'm going to multiply it by -2, which is going to give me an equation of -24C minus 2G equals -212. I'm going to add this to my equation 50C plus 2G equals 420. So we're going to add these two equations together, and -24C plus 50C is 26C. My G's cancel out, and -212 plus 420 is 208. I'm going to divide both sides by 26, and C is going to equal 8. So I know I'm going to have 8 cows. To find the number of goats, I'm going to substitute this into one of my equations. For instance, I can take my 12C plus G equals 106, and I can substitute in 8 for C and solve for G. Well, 12 times 8 is 96, so 96 plus G equals 106. And then I'm going to subtract 96 on both sides, and I'm going to get G equals 10. Therefore, Old MacDonald has 8 cows and 10 goats. How could I check this answer? I could plug each one of these back into both of my equations, and if it works for both, meaning I get a true statement, then I know I have the right answer. Question 44. Which of the following graphs represents the linear inequality y is greater than -3x plus 5? Well, all 4 of these graphs have the same graph line, where the y-intercept is at 5 and the slope is down 3 over 1. So we don't need to worry about that. First thing we need to worry about is this greater than symbol. This greater than symbol means that we have a dashed line instead of a solid line. So we can cancel out A and C because we know we're going to have a dashed line. Finally, we need to just figure out which side to shade on. So I'm going to pick the point 0, 0, and I'm going to plug it in. 0 is greater than -3 times 0 plus 5. 0 is greater than, well, -3 times 0 is 0 plus 5. So 0 is greater than 5. This is a false statement, which means 0, 0 is not a solution, so we cannot shade on the side where 0, 0 is, which means D is the answer. We need to shade on the side opposite from 0, 0. Question 45. A company makes skateboards and scooters. Skateboards cost $38 each to make. Scooters cost $47 each to make. They can make at most 1,000 total items. They can spend at most $25,000 to make all of the items. Let X represent the number of skateboards they can make. Let Y represent the number of scooters they can make. Which of the following systems of inequalities could be solved to find the number of skateboards and scooters they can make? So skateboards cost $38 each, so 38 times X, and scooters cost $47 times the number of scooters we have. If we add these together, that's going to be the total amount we're going to spend to make our skateboards and scooters. We can spend at most $25,000. So this amount here has to be less than or equal to $25,000. They cannot spend over this amount of money. They can also make at most 1,000 total items. So the number of skateboards they make plus the number of scooters they make has to be less than or equal to 1,000. They can't make more than 1,000 skateboards and scooters combined. So if we look at our options, we can see that D is going to be our solution. So which of the following systems of inequalities could be solved to find the number of skateboards and scooters they can make? D is the answer. Question 46. Lance needs to work at the Wiggly Piggly supermarket and at his family's bike shop. Lance's parents say he can work no more than 14 hours each week. Lance is fine with this as long as he makes at least $200 a week. The job at Wiggly Piggly pays $25 per hour, while the job at the bike shop pays $10 per hour. Let W represent how many hours Lance works at Piggly Wiggly. They're going to switch between Piggly Wiggly and Wiggly Piggly, so let's just call it the Piggly Wiggly. And let K represent the number of hours Lance works at the bike shop. Write a system of inequalities to represent this situation. So we've got two constraints. We've got an hours constraint, a time constraint, and we have a money constraint, a revenue constraint. So his hours constraint is that he can work no more than 14 hours each week. So the amount he works is W, that's the hours of the Piggly Wiggly, plus K, which is the hours of the bike shop. And this must be less than or equal to 14. For his money, we know that the Wiggly Piggly or the Piggly Wiggly pays $25 per hour, so 25W, and the bike shop pays $10 per hour. So 10K, and we want to make at least $200 a week. So this total amount right here needs to be greater than or equal to 200. So next we're going to graph this system of inequalities below. To do this, we're going to find now I'm going to call them the W and the K intercepts. So let's start with W plus K is less than or equal to 14. My W-intercept is when K is 0, so W plus 0 has got to be less than or equal to 14, so W is going to be less than or equal to 14. My K-intercept is when W is 0, so 0 plus K is less than or equal to 14, so K is going to be less than or equal to 14. Because it's less than or equal to, we're going to have a solid line, and we're going to have our points at 14 and 14. I cannot draw a straight line with this, so just bear with me. It's actually not too bad. Our next equation is 25W plus 10K is greater than or equal to 200. All right, we know that the W-intercept is when we have K is 0, so 25W plus 10 times 0, which is 0, is going to be greater than or equal to 200. If I divide both sides by 25, I get W is greater than or equal to 8. My K-intercept is when W is 0, so 25 times 0 is 0, so I have 10K is greater than or equal to 200. I'm going to divide both sides by 10, and K is going to be greater than or equal to 20. So my points are going to be at 8 and 20. I'll actually do this in a different color. We've got 8 and we've got 20. So we're going to connect these. Again, we know it's a solid line because it's greater than or equal to. Now, to figure out the side that we're shading, let's start with our first equation. W plus K is less than or equal to 14. First of all, we should label this. This is our hours constraint. It is our W plus K is less than or equal to 14. Because it's less than or equal to, it's going to be below the line. 14 or less on both sides. If I plugged in 0, 0, 0, 0 would be true, so we would be shading this side of the equation, of the line. For my red one, that's my money constraint. And for this, we want greater than or equal to 200, which in this case means we want greater than or equal to 8, and k being greater than or equal to 20. So we want everything on this side of the line. And where they overlap is where our solutions are. So where they overlap is in this section. So this is going to be where I shade. And this is my solution set. Doesn't need to be perfect, but I need to be able to tell what the solution set is. So the last part asks us to pick one point in the viable region and show that its coordinates meet the constraints in the problem. So I'm going to pick a point. It doesn't matter what point. I'm going to pick maybe 10, 2. What this point means is that Lance works 10 hours at the Piggly Wiggly, and 2 hours at the bike shop. So to show that the coordinates meet the constraints in the problem, we're going to plug in these points. Our first inequality is w plus k is less than or equal to 14. So we're going to have 10 plus 2 is less than or equal to 14. 10 plus 2 is 12. 12 is less than or equal to 14, so this is true. Our other inequality is 25w plus 10k is greater than or equal to 200. So I'm going to have 25 times 10 plus 10 times 2 is greater than or equal to 200. 25 times 10 is 250. 10 times 2 is 20. And 250 plus 20 is 270. Since 270 is greater than or equal to 200, this is true, and we've picked one point in the viable region, and we've shown that its coordinates meet the constraints in the problem. Question 47. Rhonda starts a tutoring business. She decides to charge $40 per hour for each high school student and $30 per hour for each middle school student. She wants to make at least $1,200 each month. She plans on tutoring 2 hours per month for each high school student and 3 hours per month for each middle school student. Rhonda decides she can tutor a maximum of 90 hours per month. Let X represent the number of high school students they tutor, and let Y represent the number of middle school students they tutor. Should say she, but anyways. First, we're going to write a system of inequalities for this situation. Well, we have two constraints. We have a revenue constraint, and we have a time constraint. Our revenue constraint is that she wants to make at least $1,200 each month. So we know that she's going to charge $40 for every high school student, which is X, $30 for every middle school student, which is Y, and that total added together is how much money she's going to make. We want to make sure that this is greater than or equal to $1,200. Then she has a time constraint. She can tutor a maximum of 90 hours per month. Well, we know that it's going to be 2 hours per month for each high school student, so 2 times X, and 3 hours per month for each middle school student, which is 3Y. And this has to be less than or equal to 90 because she cannot tutor more than 90 hours. Next, we're asked to sketch the solution to the system below. So the first thing we're going to do is find our X and Y intercepts. So let's start with our revenue, which is 40X plus 30Y is greater than or equal to 1,200. My X-intercept is when Y is 0, so 40X plus 30 times 0, which is 0, is going to be greater than or equal to 1,200. I'm going to divide both sides by 40, and I'm going to get X is greater than or equal to 30. My Y-intercept is when X is 0, so 40 times 0 is 0, and I'm going to be left with 30Y is greater than or equal to 1,200. divide both sides by 30, and y is going to be greater than or equal to 40. So if I plot these, I'm going to have my x-intercept of 30, my y-intercept of 40. I know it's going to be a solid line because it's greater than or equal to. So we'll take our ruler, it's the best I can do, and graph the line. So this is going to be our revenue constraint. We also know that we're going to be shading x is greater than or equal to 30, y is greater than or equal to 40, so we're going to be shading on this side. So I'm just going to do that right now. So if we were just graphing that inequality, that would be our answer. However, we also have to do 2x plus 3y is less than or equal to 90, which is our time constraint. So my x-intercept is when y is 0. So 2x plus 3 times 0, which is 0, is going to be less than or equal to 90. Divide both sides by 2, x is less than or equal to 45. My y-intercept, that is when x is 0, so 2 times 0 is 0. I'm left with 3y is less than or equal to 90. Divide both sides by 3, and y is less than or equal to 30. So I'm going to plot these 2 points. Oops, not there. We have x is less than or equal to 45, and y is less than or equal to 30. Again, we know that it's a solid line. And we know that we're going to be shading x is less than 45, less than or equal to 45, and y is less than or 30. So we're going to be shading on this side. Our solution is going to be where our inequalities solutions overlap, which is this section right here. So this is our solution to our system of inequalities. Oh, and I forgot to label, but this blue is my time constraint. You should always label and keep everything straight. All right. Part C wants us to state one viable solution and show that the solution fits the constraints of the problem. I'm going to pick a point like, I don't know, 35, this point right here. So if I pick 35, what this represents is Rhonda tutors 30 high school students and 5 middle school students. We need to show that the solution fits the constraints of the problem. So we'll start with our first inequality, which is 40x plus 30y is greater than or equal to 1200. Well, I'm going to plug in 40 times 30 plus 30 times 5 is greater than or equal to 1200. 40 times 30 is 1200. 30 times 5 is 150. And that's going to be greater than or equal to 1200. Well, 1200 plus 150 is 1350, which is greater than or equal to 1200, so this is true. Our other inequality is 2x plus 3y is less than or equal to 90. Just like the last one, we're going to plug in 2 times 30 plus 3 times 5. We're going to see if that's less than or equal to 90. 2 times 30 is 60. 3 times 5 is 15. We want to see that that's less than or equal to 90. And 60 plus 15 is 75, which is less than or equal to 90. So this is also true. So we've now shown that 30 high school students and 5 middle school students is a solution that fits the constraints of the problem. Our last question is, at what point do the lines intersect? Well, the lines intersect right around there, which is the point 15, 20. And that is the end of our Algebra 1 semester exam review.